Back to the old drawing board. We're on 7.4 now. This is very similar to what we've been doing. I'm not going to answer that question yet. Or request, I guess it was. We're just going to explore more ways to deal with finding values for the trig functions. So much like sum and difference, now we're going to be able to cut in half and double those angles and maybe get solutions off the unit circle. Okay, so here are the double angle identities. So I'll write them down and then I'll show you an example or two. Okay, and these should be on your sheet, I think. So. They're a little easier to deal with sometimes. Yeah, so that's a doubled angle. See, times 2, right? Sine 2 theta is 2 sine theta cosine theta. Okay. Okay, here's one way we're going to use these. And I'm going to write that one up alone and show you an example here. So if sine theta is 2/3, and I think that's going to have to say something different. Let me make sure. Theta has its terminal side in quadrant 1. Find the value of sine 2 theta. Do you know what this means, right? The terminal side of an angle is where it terminates. So that would mean this angle terminates in quadrant 1. Okay, makes it easy because everything's positive, right? So that's what you're looking at. So lots of ways to do this. We could go the triangle route and say, well, sine is 2/3. That's opposite over hypotenuse, correct? Right. To find sine 2 theta, we also need cosine, right? Because that's the identity. So we need sine and cosine. So what's the cosine here? Yeah, x over 3. So we have to solve the Pythagorean theorem here to find x. Okay. So uh, 9 minus 4 is 5, so x is the square root of 5. Again, be careful here that you check, is this x positive? Yes, it is. It's a positive x value. If it was this direction, it would be negative root 5. Because that can be positive or negative, right? The square root of a squared. So just, that's why this is important. So check that. All right, so cosine is root 5 over 3. Yeah. Okay, so now we have all the info we need. So sine 2 theta is 2 times sine times cosine. 4 root 5 over 9. Okay. Your book actually does this a different way than the triangle method. Okay. Your book uses this identity. To find cosine theta. Okay. So 2 different ways to do it. I can plug sine in here. And I can solve that equation for cosine theta and get this answer again. Okay, so a couple ways to do it. This is a more geometric argument. This is much more algebraic. What? Yeah. You just have to be careful that your positives and negatives work. Okay, yep. So do you want me to finish this one? Or you think you could solve that? You want me to?
Yeah.
Oh, okay. 2/3 squared is 4 over 9, right? And I'm going to write this as 9 over 9 because we have common denominators. Okay, subtract. So cosine squared, that is not an S. Okay, thank you. Is 5 over 9. And then square root it. So cosine theta is root 5 over 3. Woohoo! Look at that. Works every time. Just be careful there again, the negatives. Okay. When you square root a squared, you always have to consider positive or negative. We can eliminate it because of where the x is. Okay. So ours is root 5 over 3. Good. Okay. You can do the same thing with cosine 2 theta, with tangent 2 theta, with cosine. Cosine 2 theta actually has 3 different ones if you want to use. It's up to you. Okay. So let's see how. So cosine can be don't get that mixed up with the other one. This is not a plus, so it does not equal 1. Okay, be very careful. Somebody always does that. I hope you break that trend. Okay, you can also do this. Okay, that's another cosine double angle identity, and there's one more. Okay, so any of those works for cosine. Take your pick. Situation dependent, if you have sine theta, I suggest using this one. Right? Cosine theta, this one. If you want both of them, you can use the top one. Right? Hi. And then tangent. And guess what? It's my favorite. Not really. Yeah. It's the messy one. Okay, thank you very much. So don't break your camera. Okay. So it's a little messier, but it still gets the job done. Okay. All right. I think you can handle those. I think you can. You're pretty intelligent group. So the other, those ones are kind of funny. Just the way that we solve them and use them. The half angle identities are a lot more straightforward to use. Okay, so let's write one of them down and then we'll use it to solve for something. Sine, they're kind of messy, but they work. So it's a half of an angle. It can be a positive or negative. And yes, it involves using cosine. Okay. Yeah, it's alpha. It's that other Greek letter we use a lot now, along with beta and theta. And yeah. Okay. Sine of power 12. Okay. We can use it to solve for angles. Okay, because I can rewrite this. You could probably use a sum or a difference identity for that if you want to. But you can also do this, because that's 7 pi over 6 divided by 2. Okay, you can use the half angle identity. Okay, just remember that fraction division, copy dot flip. Okay, because we have a value on our unit circle of that, don't we? Okay, because it's double this. What's 7 pi over 6? Okay. 7 pi over 12 times 2 is 7 pi over 6, right? That tells us what we need to use here, because we're going to take half of it. Half of this gives you back there, right? So these half angle identities make these a little more simple in that it is positive or negative 1 minus cosine 7 pi over 6 over 2. Okay, and we know this off the unit circle. On most normal days, not today, right? Anybody? Oh, come on. Snow in your brain. 7 pi over 6 cosine, go. Okay, go. Negative. You almost got it. Thank you.
What is that bottom part that you wrote?
This is how I calculated this number. Okay, so if you, let me see, yeah. If I take 200 times 2, what do I get? 400. Right? Yes. Okay, now if I put 400 back in here, divided by 2, it's 200, right? Yes, so all you're doing is playing with the doubles and halves. So I double this number to figure out what I need to divide by 2, half it. Because this is the same as this, right? That's the idea. So we can use this number in our calculations because we have that number on the unit circle. So if I double this, it gives me the top of this fraction. Because we're dividing it by 2, which undoes that, right? Yeah? No, you don't understand. Fog? Fog. Thank you. Good. Do you want me to finish that one? Okay. Okay, common denominator on the top here, right? And then I'm going to write the bottom as a fraction. So that's 2 over 2. I just combined it into one fraction. Copy dot flip there. So we get 2 plus root 3 over 4. And root, what's the square root of 4? 2, yeah. So you can simplify the denominator right there. Yeah, it has 2 square roots in it. Yep. Okay, now how do we deal with that? Is it positive or negative? That's the question. We'll go a little Shakespeare on you. Is it?
Wait, if it's in quadrant 3, wouldn't it be negative?
7 pi over 12. Right, that's our original angle. Right? Is sine positive or negative?
Nick?
7 pi over 12. Is sine positive or negative? Thank you. It's the y values. Sine is positive. Okay. Now this is where people get confused. Okay. I was hoping you'd jump on it, but okay. The original is 7 pi over 12. That's what we're analyzing. That's what this is, right? So that is the angle we consider for positives or negatives. We used 7 pi over 6 in that calculation, right? But the original angle is 7 pi over 12, and that's the one we have to use for sine and cosine. Okay. Now 7 pi over 6, yes, is negative for sine. You are correct. But be careful with that, because you have to use the original angle. Okay. So this is actually positive. Yeah, I know you're bored. Trust me. Okay. Now I gave you radians there because they're a little more difficult to see. All right. Just messing with the fractions. Doubles and halves. That's what you're looking for. Okay. But like I said, you can also solve a lot of these with sum and difference that we worked with last two days of class. Okay. Let me give you one real quick and we'll be done with the degrees. So I think you'll be less confused. Okay. What is the cosine of 67.5 degrees? That is the same as, what's times 2? 135? That right there, correct? This you could double, yeah, but we already doubled this one. So we're looking for the value of this, right? We double it, it becomes 135. Does that occur on the unit circle? Is 135 on the unit circle? Yeah, it is. So we don't need to double it again. This is the doubled number.
So then you just leave the over 2 out.
Yeah, when you solve here, this is taking care of it. Okay. Bang head here. Okay, good. So if you're dealing with something that you can double and have an angle measure of it on your unit circle, you need to use a half angle identity. They work in tandem.
Wait, so
Okay.
if you find something you can double, you have to half it?
Exactly.
Yeah, it's the opposite. Is that what you're saying?
Why is this not clear? I don't know. This is not that. No, it's not.
No, it's pretty hard.
You can multiply and divide by 2, right? Okay. It's the bigger idea.
Double to find the calculation.
It's like adding. Okay, so
Divided by
is
the end.
this on the unit circle?
No.
Okay. No, big fatty. Okay, thank you. Is 67.5 times 2 on the unit circle? Yes. There. Okay. That's our aim right there. Okay. That is right here. Okay. But we have to keep our original angle. 135 divided by 2 is 67.5. So we're going to use this to solve this problem. Does that help?
So,
You're just saying yes, so I'll shut up.
Yeah.
Thank you very much. Okay. What is the cosine of 135?
Negative square root.
Is it negative?
negative.
Thank you. And you can solve that. I know you can. It's the same as the last problem. What were you going to say before I interrupted you? Bull crap. Now he's lying to me. That's awesome. Thank you for participating in class today. I will go sit at my desk the rest of the hour. Darn kids. Okay, I'm good. Deep breath. I'm good. Does this make sense now? A little bit better with these two questions? Okay, so you have ways to solve these things. Okay, let's summarize. Okay. Okay, Thursday and Friday. Okay, we have identities we could add or subtract, right? We did that Thursday and Friday with sum and difference. So keep in mind, you can add or subtract to get the total, right? Okay. We also today added multiplying and dividing. So you're basically manipulating angle measures to be able to use the unit circle. Okay, that's the big idea with the last 3 days of class. Can you add or subtract or multiply and divide to make an angle on the unit circle so you can use it? That's it. Okay, so that's the hope here that we're doing this stuff. All right. Okay, I'm good. I'm going to go ahead and be done because I don't want to screw things up any worse. What? That? Yeah, I'll finish it. Okay, if you're good to go, here's your cruel and unusual punishment, as if being here is not enough. It was supposed to be a snow day. Shut up, Richard. Okay,
God, I hate this thing.
44 has degrees, minutes, and seconds. Use these decimals for that translation, okay? Most of this assignment is review.
Is that 11 or 4? That's 4. I mean 11.
I think you can answer that question.
I'm gonna assume it's 6 or 4.
Okay, have fun with that. Okay. Okay.
See, he says we don't have to do that.
Okay, so if we're going to finish this problem, again, everything here revolves around fractions. We do these all the time, right? So I've made a common denominator. So this is 2 over 2. So I get 2 minus root 2 on top, and then root 2 on the bottom. Okay, good. And now I can copy dot flip, and I get 2 minus root 2 over 4. Yes, it is. And then we can square root 4.
I don't know what I'm doing right now.
Yeah.
I can see that. Okay.
So you make the fraction.
Do you understand what I did here?
Like barely.
Okay, what's 1? Is 2 over 2 is 1, right?
Yeah.
Now I have a common denominator. And I have 2 minus root 2 on top, 2 on the bottom. And then I rewrote this as a fraction. Now I'm going to copy dot flip. Copy, multiply by 1 over 2. 2 times 2 is 4. Yeah?
Which line were we supposed to
Don't tell me I did something wrong.
How do you, like, that's why, like, 2 top and bottom, but there's no 2 square root of 2. Just in front of it. Yeah, I did not make sense at all.
Are we here? Here? Is this where you, no, here.
Just how do you get like the 2 on the top and bottom without having it on the square root?
The square root already has a 2 under it. So we don't want to change that fraction, right? So it's still going to be root 2 over 2. So this one doesn't get changed. Give me some feedback here. Yeah, you okay with that? Not okay with that? Okay, I'm trusting you here. Oh, I can't trust myself right now. Okay, is it positive or negative?
Apparently it's positive.
Would be negative.
The book says it's positive, so that's what it is.
Canyon says it's positive.
Oh, well, from now on, we refer to Canyon for all our answers. Okay.
Might as well.
Wouldn't it be negative? Good.
No, it's fine. It's positive.
Again. Oh, that's not what I want.
Positive.
Cosine is
Positive.
positive for 67.5. That's the angle, 67.5 degrees. Cosine is positive, so positive. I'm going to go bonkers here. Okay. Please pray for me for the rest of the day that I don't screw anybody else up. I'm done.
I'm done.